Okay, hello and welcome to another past paper session. Um, the paper we're solving today is March 2025, paper 1 for A level math. Okay, the first question says a curve has equation y equals to 5 plus 3x minus 2x squared, and a straight line has equation this, where k is a constant. Find the set of values of k for which the curve and the line do not meet. Okay, so I will first put them together. Okay, bringing everything on one side gives me 2x squared plus kx 3x plus 8 equals to 0. A is 2, b is k minus 3 is 8. For which the line and curve do not means b squared minus ac 0. B squared minus a times c is less than 0. So k minus 3 whole square is 0. Solving it the easy way would be to say that take a root both sides. I get k minus 8, k minus greater than minus. So k is less than 11 and 5. So k is between minus 5 and 11. Okay, let's check if that is the correct answer. Yep, that is the correct answer. Move on to question number 2. Question number 2 says the diagram shows a curve with this. The curve crosses the x-axis at the point this and m as a minimum point. This is a question on differentiation. Okay, first what I'm going to do is say that we brought up dy over dx equals x plus 5x power minus 2. Okay, then gradient of the curve is basically 9. Let's check if that is the correct answer. The correct answer. Then it says find the coordinates of m. So m is the minimum point. So dy by dx has to be equals to 0. So 0 equals to 5x 5 over x squared. Moving everything, not everything to one side. So minus 5 over 4 equals x cubed. I will have to open up later here. So minus 5 over 4, the cube root. So that gives me x equals to minus 1.08. Yep, that is correct. It says coordinates, so I also have to find the y coordinate. The y coordinate is basically 2 minus 1.08 square minus 8 plus. Okay, so calculating that again, 2 into minus So 9.9. So m is basically minus 1.08. Okay, find the complete expansion of this. Complete expansion is easy. You start off with term number 1. That's 4c0, 2x power 4 minus 0, minus 3 over x power 0. Term number 2, 4c1, 2x power 4 minus 1, minus 3 over x power 1. Term number 3 is 4c2, 2x power 4 minus 2, minus 3 over x. Term number 4 is 3, 2x power 4, 3. Term number 5 is 4, 2x power 4 minus 4. 2 power 4 is 16x power 4. 8 into 4 is 32. 32 into 6, so that's minus 96x square. Okay, what's 4c2? That is 6, 4. That's 216. With the positives, that's x square over x square, so that's a constant. 4c3 is 4, into 2 is 8, into 27. Minus 216. And now you have x squared in the denominator. And 3 power 4 is 81. That's 81 power 4. All those are correct. I can write them in one line. Plus 216 minus 216 over x squared plus 81 over x 4. Okay, all of those are correct. Hence, determine the coefficient of x squared in the expansion of this. So x squared plus 5, and can I borrow this from here? Okay, so I have to decide which of the terms will give me an x squared in the numerator. So this multiplied with this constant gives me an x squared, and this multiplied with this gives me 96 into 5 x squared. 96 into 5, 480. So 216 x squared minus 480 x squared minus 264. Okay, that is the final answer for this one. Let's look at question number 4. Question number 4 is the diagram shows OAB where OA equals to OB equals to 10 and angle OAB equals to 8 radians. The shaded region is bounded by the arc CD and the line segment is this, and the perimeter. So the first thing that I have to do is find CD. Arc CD is r theta. Okay, then I have to find the length AB, which is the side of the triangle. I think I can make it easier by just saying that this has to be 0.4. I can use sine cos tan. I can use 4 equals to, let's call that x, ax over 10. I will have to change the angle unit. Okay, so sine 0.4 to 10. 3.89, so ax is 3.84. So when I'm doing perimeter, I'm going to say 4.8 plus 2 times 3.84 plus 4 plus That gives me 20.6. Let's verify. Yep, 20.6 is the correct answer. And the area of the shaded region, so that's just area of triangle minus area of sector. Area of triangle is half A B sinus C, and area of sector is half or square is square and theta is. Just typing on my calculator. 57.388. 14.57.388. 14 point. That gives me 42.988. That's 43 point. It's a mistake then. Maybe calculation mistake. Ten into 10. That has to be 35.868. That's only a calculation mistake. Question number 5, it says an arithmetic progression has first term 5 and common difference 6. For this progression, find the sum of all the terms that lie between 150 and 400. So I'll have to first find out which term is 150 and which term is 400, because I can't say for sure what term number that is. So I am going to say that there's a term n, a plus n minus 1d. Okay, d6. Okay, so this term number n is between 150 and 400. So 6n minus, if I simplify this becomes 6n minus 6 plus 5, which is 6n minus 1. So 6n minus 1 is between 150 and 400. Okay, solving for n gives me 151,401. What's 151 divided by 6? So 25.17, and d6.8. So I am looking at all terms from 26th term to 66th term. So what is the 26th term? It's a plus n minus 1d. So 5 plus 25 into 6. 155. That's term number 26. It's term number 66. It's 5 plus 65 times 6. 545. I think I made some mistake here. Okay, that's 395. Okay, so sum of all terms is basically n over 2, a plus l. I have a, I have l. N is the number of terms, so 66 minus 26 gives you 30, plus 1 is 31. 31 terms, so 159 plus 395. I thought I was doing it a longer way, but this has a lot of marks, which this is the best way out. So divide by 2 gives me 85, 25. Then I've done something wrong. Oh, sorry, this is 41. N basically has the formula last minus first over common difference plus 1. We don't know that already. So 11275. Okay, moving on to question number 6. It says the diagram shows a circle of radius r where x is greater than 0 and y is greater than 0 for all points. The least distance between any points on C and the x-axis is 8 units. So this height is 8 units. Okay, and the least distance between any point on C and the y-axis is 5 units. This is 5 units. Okay, state the coordinates of the center of the circle. So if you go up, the y coordinate becomes 8 plus r, and this x coordinate becomes 5 plus r. So the x coordinate is 5 plus r, comma 8 plus r. Given that the distance between the origin and the center of the circle is 15 units, so that's easy. Then I can use the distance from the origin. I can say that the distance from the origin is going to be 5 plus r minus 0 whole square, and 8 plus r minus 0 whole square as well, equals to 15. That gives me 10 plus 2r plus square plus 16 plus, sorry, 64 plus 16r plus r squared equals to 225. I've squared both sides. Okay, so this gives me 2r squared plus 18r plus 74 minus 2r squared plus 18r. 1. Sounds like a weird number, but let's see. No, I think I've messed something up. Check if my answers were correct. Okay, there has to be 25. That's a silly mistake. 25 plus 64 minus 2. Going to give me a minus 1. Let's check if we have the right answer now. Do I have something else wrong? This is 10R. Let's do this question again. Okay, so 5 plus R whole square, 8 plus R whole square, root equals to 15. Okay, squaring both sides and then opening up the squares. 25 plus 10R plus R square plus 64 plus 16R plus R square equals to 15. So 2R square plus R minus 130 square basically. Why? Because I've removed the root equals to 0 then. Let's check if we have the correct numbers now. 226 and R is equals to 4 or R equals to minus 70. Not possible. The point on the circle furthest from the origin is denoted by P. Find the gradient of the tangent to the circle at P. Okay. The farthest from the origin would be something that passes through the center and goes like that. Now I want to find the tangent here. Okay. I can't certainly find the tangent, but it's going to pass through the center, so I can find the gradient of this line. Okay, so if R is 4, then this point has to be 9 comma 12. The gradient would be y2 minus y1 over x2 1, so that's going to be 4 over 3. Okay, and if I make it perpendicular, it gives me the gradient of the other line minus over 4. And that should be the correct answer. Yes. Moving on to the next question. Question number 7 is trigonometry. Show that this is identical to that. Um, okay. It's best if I use this because I see an easy identity being used here. So I can take a common denominator and say cos square theta is the common. So I have 3 sine square theta plus 5 sine square theta, 1 minus sine square theta. So 3 sine square theta plus 5 sine square theta minus 5 sine power 4 theta. And the denominator can be written as 1 minus sine square theta. So 8 sine square theta minus 5 sine power 4 theta over 1 minus. Okay. Then I have to solve this equation. So this is from the previous part only. Copy this part. Equals to 9. So 8 sine square theta minus 5 sine power 4 theta equals to 9 minus 9 square theta. Bringing it to one side, 18 sine square theta minus 5 sine power 4 theta minus 9 equals to 0. I think I should move it to the right hand side because I see a disguised quadratic forming. So I have 5 minus 17, 9. Okay, I just want to check if I've done everything else correctly. So y equals to sine square theta. So that would give me 5y squared minus 17y plus 9. So y gets me two values. Let me check if these are the correct values. Yeah, they have to be smaller numbers, so I think we're doing fine. Okay, so y can be either 2.744 or y can be 0.655. Okay, so sine square theta can be 2.744 or sine square theta can be. Okay, the root of 2.744 is sine theta equals to 1.656. That's not possible. Sine has to be between 1 and minus 1 and root of 0.655. So sine theta is. Okay, I'm going to solve this further and say that I have to go up to 0 to 270. Okay, this is going to be both plus and minus. So there are going to be two answers. One which is a plus. They're going to have the same basic angle, sine inverse of 0.809. So that's alpha equals to 53.998. So that's in the first quadrant and in the second quadrant, and that one's at the third quadrant. So quadrant 1 will be 53.34.0 basically. Quadrant 2 is going to be 180 minus 54. That is going to be 106. And quadrant 3 is going to be 180 plus 234. Okay, that is that question. Moving on to question number 8, it says a geometric progression is such that the second term is minus 120 and its progression is such that the second term is minus 120 and the sum to infinity is 160. So sum to infinity is 1. But I'm recording for future queries. Term number 2 is minus 1. So a over 1 minus r is 160 and ar is minus 1. Okay, so I can replace a with a. So it's going to be 160 minus 160 r. 160 minus 160 r equals to minus 1. So 160 r minus 160 r square equals to minus 120. 160 r square minus 160 r minus 1. Over 2 and minus half. This is discarded. Why? Because if r is greater than 1, you cannot have a sum to infinity. Okay. Okay. And that's correct. Thus the first 9 terms of the progression are now removed. Find the sum to infinity of the remaining terms of the progression. The sum of 9 terms. A, I will have to find out A. It's 240. Power n. So that gives me 160.3125. There's likely some mistake here. Let me check. Okay, yeah, I think my answer is correct. Then the sum to infinity is the difference between sum to infinity and sum of 9 terms is 160 minus 160.5. What I was also confused about is yes, the sum of to infinity can be a negative number as well, so that's absolutely fine because the terms might be negative. So a little confusing, but yes, that's the correct answer. Okay, question number 9. A curve is such that d square y over dx square equals to this. It is given that the curve has a stationary point at 12, 9. Use the expression for this to determine whether the stationary point is a maximum or a minimum point. Okay, so you just plug in the point. That's 40. 16 into 6 is 96. That gives me 56. Positive. Therefore, minimum. Okay. Then find the equation of the curve. So I have to integrate it twice. But I get dy by dx first. Okay. dy by dx will be 0 at this point. Okay, so that's 6 over 8 divided by minus 3. So minus 6 over 24. And 4 into 8 plus 5 over 8 plus c equals to 0. Three over 8 c. Okay. Then question number 10. Question number 10 says the diagram shows a curve with equation this. For values of x such that x is between 0 and 7. Okay, I have to do something else as well. Oh, I have to find the equation of the curve. I haven't done that. I'll have to integrate it once more. So dy by dx equals to minus 2x cubed plus 5 over 2 x power minus 2 minus 3 over 8. Let's integrate once again. Minus 2x power minus 2 over minus 2 plus 5 over 2 x power minus 1 over minus 1 minus 3 over 8 x plus d. Then I plug in these numbers that I have, 9 and a half, 9 and so 9 minus 1 over 4 plus 5 over 4 plus 3 over 16. That's 4 over 4, that's 1, 9 minus 1 is 8. 8 plus 3 over 16. 131 over 16. Let me check if that is the correct answer. Oh, I've messed up some calculations here, I think. Oh, that's half power minus 2. That has to be 4. It's also half power minus 1. So 5 Is my first C correct? The first C is also not correct. If I've done that here, I've probably done that here as well. Okay, let's solve this again. Okay, so let's just do a calculations on the calculator. I measured the calculations earlier. So 6 into 0.5 cubed divided by -3. So that gives me -1/4. 5 into 0.5 power -2 divided by 2. I've again done something. -16. That's 10 plus C. So C is 6. Then I integrate this again, dy by dx equal to -2 power -3 plus 5/2 x power minus plus 6. When I integrate that, I get y equals to plus d. So plugging that number again, 9.5. 9.5. 9.5. So half power -2 plus 5/2 minus 5/2 half power -1 plus 6 into half plus d. So 0.5 power -2. Okay. Okay, question number 10 says the diagram shows a curve with equation this for values of x. This the tangent to the curve at the point this meets the y-axis at the point Q. Region A is bounded by the curve and the two axes. Region B is bounded by the curve and the line segments. Find the area of region A. So I will have to first find out what P is. For P, I think I have this. So I basically integrate from 0 to 7. What do I integrate? I integrate this entire thing. So 4, 3x 4 power half plus 1, 3/2 into 3, minus 2x square over 2 minus 6 from 0 to 7. Okay, so that's 9/2. 4 divided by 9/2 means 4 into 2 over 9. 3x plus 4 power 3/2 minus x square minus 6. Then you plug in the limits 7 and 0. So that gives you 8/9 into 20 into 7 is 21. 25 power 3/2 minus 49 minus 42 minus 8/9 4 power 3/2 minus 0 minus. Okay, 5 cube is 125. 125 into 8 is 1000/9 minus 91 minus 64/9. Let's do that on a calculator. $104. That's 4 and 9 is 13. That should be the correct answer. Yeah, that is the correct answer. Go on to part B. Find the area of region B. Region B is basically subtraction of the line. If I can somehow just find the triangle here, it's a tangent. So let's first work on the tangent. Okay, so I'm going to calculate dy by dx. Say that this is half. That comes down to 4. 3x plus 4 power half minus 1 to 3 minus 2 minus 0. So dy by dx at 7. 21 plus 4 minus, that's 6 into 25, 6/5 basically, minus 2. That gives you a minus 4/2, minus 4/5. Okay, so that's the gradient of the tangent. If B has the coordinates 0, y, with B being 7, 0, then I can say that y2 minus y1 over x2 minus x. I just want to check if B's coordinates are correct. Yeah, I think that's correct. So half base into height. (98/5), and then you subtract the area that A had, so 98/5 minus 13. Okay, I think that should be the correct answer. 33/5, yes. Okay, let's look at part question 11. That's the last question on the exam, I think. Yeah, that's the last question on the exam. It says functions f and g are defined for this, where c and k are positive constants. It is given that g inverse of 3k plus 1 equals to c. Show that g f of x equals to 8x squared minus k minus 1. So g f of x is 2x to 4x squared minus c plus k. That's what I have right now. I have 8x squared minus 2c plus k. So that's g f of x. But Ben seems to be acting weird today. So gf of x is this. Okay, I had to prove that this is equals to this. So this is not the case. I want to somehow replace c with k. So I'll have to use the other idea as well. What is the other idea? That g inverse of 3k plus 1 equals to c. So when I say g inverse of something, that means that typically this is the value of x and this is the value of y. When I use the inverse, this is the value of y for x. Okay, so this basically means that 3k plus 1 equals to g of c. Okay, so I can use that. So g of c is 3k plus 1, so I'm going to write 3k plus 1 equals to 2c plus k. And then I'm going to solve for k, so that's 2k plus 1 equals to c, and 2c can then be replaced here. I don't need to do c, just replace it here. 8x square minus 2k plus 1 is k. 8x square 8x square minus k. So that is how you would show this part. Okay, part b, the curve with equation this is transformed to the curve equation y equals to h of x by the following sequence. A translation of 2 3 stretch in the y by scale factor of k, reflection in the exact. Okay, so we'll do it step by step. So first, in terms of the transformation, I can write x minus 2 and plus 3. So this is going to be y equals to 8 x minus whole square minus k minus 1 and then a plus 3 at the end. Okay, so that's the first one, stretch in the direction of y by a scale factor of k. So this becomes kf of x. I'm going to multiply everything by k. So this will be 8k minus 2 whole square minus k minus 1 plus, sorry, my bad. So this is going to be minus everything by k. So minus k square, and this end part is going to become 2k. Then a reflection in the x-axis means that I want to do minus f of x. That's going to be minus 8k minus 2 whole square minus k square plus k square minus 8k. Okay, so finally h of x should then be minus 8k minus 2 whole square plus k square. I'm going to exit and come back. Okay, then says the range of values is given by this. Find the values of c and k. So basically what I have is h of x. I have h of x in terms of the completed square form. See that? Okay, where the x turning point has the x coordinate 2 and the y coordinate as k square minus. So if this is 15 and this is a sad face curve, as I can see from the numbers that I have, this point is 15, which means that k square minus 8k is equals to 15. K square minus 8k minus 15, 0. I'm just seeing if I have the numbers. Yes, just check. Yeah, I have the numbers right. K square minus 2k, not k square minus 8k. I think I've done some calculation mistake. Where did I get 8 from? Let's go back and check. Oh, this was 2. This was never supposed to be 8. It's 2k. It's 2k. 2k. This is also 2k. I wrote it badly, so I copied it badly. Okay, so that's simple then. K is either 5 or k is minus 3. Let's check back if we know something about k. What do we know about k? K and c are positives. So k is positive, so k is 5. If k is 5, then how do I calculate c? I think I have c somewhere here. Yeah, 2k plus 1 to 2c. So 2k plus 1 equals to 2c. C equals to 11 over. Is that correct? Yeah, that is the correct answer. That brings us to the end of the exam. Thank you for watching.